Okay, oh, there we go, perfect. Okay, this is lightning talk, so I gotta go fast. So the thing we gotta say before I start is that I'm gonna be showing you some results of tests I ran. These were all run on the OVS sandbox on my laptop. So the numbers you see are a your mileage will vary sort of thing. Don't take the numbers for gospel. The important thing though is that the change you see in the values is significant. So the first thing we're going to talk about is OVN NBCTL daemonization. It's a change that we ran into when trying to sort of run through some OpenShift sized clusters testing. So basically, if you take anything from these numbers listed here, you can see they're just very large numbers, and we're setting up a large cluster. The highlighted bit is the very important bit, which is that we make over 73,000 calls to OVN NBCTL during this test. So let's see what happens when we run it. When we run it, it takes 12 hours and 40 minutes about to finish. So if you map the actual each iteration of the test, so in other words, each pod that we create in this cluster, so to speak, you can see it has the awful up and to the right trend. And it ends up taking over 7 seconds per pod to create towards the end. So OVN NBCTL daemonization fixes this issue because OVN NBCTL has to download the entire contents of the database every time that it needs to run. So daemonization means that you have a continuous running process so that it's only having to download the changes to the database throughout the lifetime of the script. And it's as simple as putting this export line into your application before running OVN NBCTL. And so by putting that in and rerunning my same script again, now when I run it, instead of taking 12 hours and 40 minutes, it's a little over 5 minutes. So that's 0.007% of the time that it took before. So that's a significant improvement. And now if you look at the graph of the iterations, you can see that the highest you see any of those lines going is about 50 milliseconds. So that's way better than the 7 seconds we had been seeing before. Another past improvement is port groups. So for this scenario, we're sort of basing this off of some OpenStack ACL usage. We've exaggerated a little bit, though. So for instance, we have an address set with a bunch of addresses in it, and then we create a bunch of logical switch ports. And every time we create a logical switch port, we create a new ACL that references the entire 1,020 IP address set and the new port that we created. We run this test with the wait equals HV, so we're having to wait for the hypervisor every time through that we add a new logical switch port. So when we run this with 1,000 logical switch ports, we can see it takes over 2 hours to run. And again, we have this awful up to the right, and it takes, you can see, sometimes over 16 seconds for a new logical switch port to get added. By using port groups, what we are able to do is reduce the number of ACLs from 1,000 down to 1, and by using a single ACL that refers to a port group and the address set, OVN controller is able to make a much more efficient way of creating the flows. So if you see what happens in the original tests, we have over 1 million flows in the integration bridge, and ACLs are taking up 99% of the total. So with port groups, what we do, we run it with port groups, and now instead of taking 2 hours, it takes 6 minutes to run. So 4.8% of the time of the original test. Again, a pretty significant change. And if you look at the new graph here, you can see it's still got the up and to the right trend, but that y-axis over there is way lower scale. So I actually put the two graphs on top of each other for comic effect, and you can see just barely maybe some blue down there from where we use port groups. And this is, of course, the awfulness of using no port groups. And you can see that the number of flows installed went down significantly, 0.009% of previously. So, future improvements. I don't have a whole lot of time to talk about this, but the big one, the big white whale, is incremental processing. What this aims to improve is that OVN North D and OVN Controller currently have to process the entire set of data in the database in order for it to do its work. And with incremental processing, the whole idea is you process just the changes to the data rather than the entire data set. But the problem with incremental processing is it's hard to do in C. So the solution is to use something called differential data log, and I am out of time. Can I keep going? Okay, cool. So differential data log is a language that has been developed at VMware by Leonid Rizhik, I think is how you say your name. It actually is a logical language that is for differential database transformation, and it actually is implemented in Haskell, and it outputs Rust. So this is, earlier in my other talk, I mentioned about Haskell and Rust being potential new dependencies for OVN, and this is why. I have some further future improvements here, but I'm just going to skip over those because I just need to go on to my next talk. So.